Welcome to the CSDR demo. Today, we are going to start our journey, as always, in Jira. We have just been assigned an exciting new bug fix. So, let's start by looking at what needs to be fixed. Okay, here we can see in this report that we have, through SonarQube, two new issues that need to be fixed. Let's start by the first issue. Okay, this is a very minor issue, presentation issue. And we can see an explanation here of why it's an issue. We are using the bold tag instead of the strong tag. Bold has no semantic meaning, so it needs to be replaced by a more meaningful tag, which in this case is strong. Okay, let's now check out bug number 2. And here we can see that it's a bit more complex bug. So here we have this condition operation returns the same value whether the condition is true or false. So we probably have a copy paste issue. So here on line 20, we can see that we have a condition and it's returning always the same method, say hi, independent of the condition being true or false. So this is something that we can fix very quickly under the 15 minutes effort estimated by SonarQube. Okay, so let's start the work by clicking on Start Work. And now let's start by creating our branch. So here we are going to use the develop branch. Here we are going to use a bug fix type, and we are going to shorten a little bit this issue. So we have here the issue name from Jira that will create our branch name. So this connects our Jira with our Git and enables us to then commit messages on this Jira issue directly and very quickly to have this integration between the Atlassian product. Let's go ahead and create the branch. Great. We can see here that we have a new branch created. Okay, we are now ready to start coding. As we can see, we have three branches here: develop, bug fix, and master. So let's jump into VS Code and start by checking out the new bug fix branch. So as you can see here, we are in the develop branch and we want to check out our bug fix MWP 944 demo test. Okay, and we are done. Okay, now let's start by actually doing our first bug fix. Here we can see the B tag that we are going to replace by the strong tag. The B tag has no semantic meaning, while the strong tag does have semantic meaning. So by doing this fix, we can see that we no longer have that error showing up from HTML lint, and we can move on to the TS part. So in our TypeScript, we can see here that we have a squiggly line indicated by sonarlint. This conditional operation returns the same value whether the condition is true or false. So this is a problem that we're having. Probably someone copy pasted this and put the wrong method being called. You can see here that this is connected to our quality gate. The same rules that we have in SonarQube, we can see them directly in SonarLint. So here we have the linting rule with the exact same explanation. SonarLint is currently available for multiple IDEs and truly helps to commit less bug fixes. So you can see here that it's available for Eclipse, IntelliJ, Visual Studio, VS Code, and Atom. And even though the rules are not the same for all of the editors, so for IntelliJ, it's mostly Java and TypeScript, and for VS Code, it's mostly TypeScript and JavaScript. It truly is useful to use this connected quality gate. Okay, now that we know a little bit more about the linting editors that we have in place, Let's now fix this issue. So we're going to simply replace the say hi with a say bye in the second method so that we do not have this condition anymore. And as you can see, the squiggly line is gone. We have no other errors. But for example, we have tslint. Now that we have a new line, giving us a trailing white space error. We do not want this, so we are going to go back into our beautifully formatted code. We are going to save both our files. You can see in the editor the M for modified. And now we are going to commit our code. So we are going to synchronize the changes. We are doing a pull to see if we have new changes, and we are going to create our conventional commit message here. This is a very important part that enables the automation of the release version. So here we are going to use the fix convention commit, and then we are going to put the issue number, and we are going to say what we did. So we are going to say that we fixed 2 bugs, and we are going to commit this message. Now we need to, of course, push our changes into our new branch. Let's now jump back into Git and see if we have our commit. Okay, we can see here now that we have our commit and our message, our conventional formatted message. And this is what enables most of the automation. To give you a little overview of how our process works, let's go into the documentation where I can explain a little bit how our Git workflow works. So we use what we call the CSDR Git workflow, which is a deviation of the Git flow that is more commonly known. And here you can see that we have our feature branches, and when we do want to do a snapshot, we do a pull request into develop branch. Once we are happy with the develop branch, we do another pull request into master to create an actual release. What this enables us to do is that we can always release new snapshots, and developers always have the latest changes that they can test against their own packages before doing any breaking changes or before knowing that the contracts have been broken. This enables us to move very quickly, and this is why we adopted this simplified Git flow. Okay, now let's go back into our repository. So let's follow our flow and start by doing a pull request. We're going to create a pull request from our bugfix branch into our develop branch. We are going to usually you can put a description here and you would add a reviewer, but because this is just for the demo, we are going to simply create this pull request and merge the changes. We are merging the changes. We are going to delete the source branch after merging because we do not want to continue working on this bug fix. And we are going to check out in develop if our changes have been done. Okay, so now we usually wait for Bamboo to pick up the changes that have been done and create a new build. You can see here that Bamboo typically will call our trigger and will put a build badge here that you can see then the build results directly. So let's wait a few more seconds. Okay, we can see now that we have a new notification in Slack. Slack is our central hub where we have all communication and all of the CI/CD pipeline connected. And we can see here that Bamboo has been triggered by in the develop branch by myself and is starting a new package build. We use Bamboo mostly just to do the calls, and we then use GitLab to actually build our project. And we can see here now that we have a new running project, which is our new package. It's the package dependencies are being pulled, and we can wait the package to be built. While we wait, I want to talk to you a little bit about GitLab. So GitLab is a very modern CI/CD system that uses runners using Docker images to actually do the build. So this allows us to always replicate the same results and always have consistent results. Here we can see the types of runners that we have. We have specific runners in the case of this one here, which is used to build my workplace every night and is available all the time. We then have a spawn runner. So basically, the spawn runner creates other runners dynamically. And you can see in our console a dynamic runner being created here. So it's just been terminated now because it's a spot instance. So these spot instances have a very short life uh, and are only used when they are necessary. So they save money and save cost by being only enabled when they are needed and by being spawned when they are only needed, usually during only business hours. And then we have shared runners. So these kinds of runners are static runners that we have created also as Docker images, and they are used to do builds. So we don't want to have all of our infrastructure being dynamic. We want to have nightly jobs running, and this is the reason for these static runners to exist. And we can see here in the pipeline the stages that we have for this build. So we have a build stage, a notify stage, and a callback stage because we are calling back Bamboo. And we just got a notification from Slack that our package has been successfully built. So here we can see that we have the scope of the package that has been built and the version of the package, as well as the commit history of the package. And we will also get the trace file. So what we see here in real time in this window here will be sent through Slack to the developer team. So if in case there are any issues, they can fix the issues. Okay, we have a snapshot package released, as you can see here, and we can continue our flow. So the next step is for us to actually see if our quality of code has been solved. And we can do this by jumping into our ZZZ package in Sonar and checking out that the quality gate has now gone from a failed state into a passed. So we have now 0 bugs, and you can see here the project activity that we had 2 bugs before, and now we have 0 bugs. So we are happy with this release, and we are ready to do a pull request into master and do an actual release. So no longer a snapshot used in development, but an actual package used in production for other developers to be able to use it as a stable product. Let's go ahead and do that. Let's go quickly into our pipeline and check that it has completed. So it's still ongoing to the second stage, and we can take this time to actually check out the statistics for all the packages that have been built. And as you can see, we are always getting notifications in Slack. So this is our chat ops, our central operation for communication and synchronization of all the files. Here we can see the trace file has been sent, and we will also get a summary of the actual pipeline built and the time that it took. In this case, because we are not using caching, it's taking over 6 minutes. Usually with caching, it takes a little bit under 3 minutes. As you can see here, for example, 2 minutes and 53 for this other package. We can see here that we have built in the past 6 months approximately 4,000 packages. So we can see the statistics for the past week. We can see the statistics for the past month and for the full last year. So we started with this specific GitLab version in April, and we have been growing and growing in the number of packages. We can see the success rate is 80%, which is an extremely good success rate, means that the automation is working, but we still have developers doing not enough linting in their editor. So this is something that we truly need to pass on to the developers, that you need to use these linters. They are here to help in the development and commit less bugs that break our build and stall our CI/CD pipe. And we are back in Bitbucket, our Git repository. We can see here that we have a release message. So this is a release chore that has been done by our functional user, buildbot ec-eui. We try to keep our buildbot very busy all the time, and we like to give him lots of tasks so that we don't have to do them ourselves. Here we can see the build badge that has been created, and we can see here, and we can even jump into the result directly of this build badge. And we can see here the issues that have been committed and the bug that has been that is being fixed, that is currently in progress because we have not finished doing our master release. We will only close it when we actually finish doing our master release. Let's go and actually do a pull request into master. We are happy. Our build into the snapshot passed, and we can now actually start a new pull request. We follow the flow and we create a new pull request from develop into master, as is illustrated here in our diagram. So from develop into master to create a new release. Let's do just that. Again, we would typically add a reviewer, and in CSDR, most repositories have at least one approved reviewer required to be able to do a pull request into develop and into master. So in this case, we don't have a required one, so we are just going to actually do our merge. And here we can actually continue to use our develop branch because we want to continue, obviously, with both develop and master. So let's do a merge and let's see the result of this merge into our master branch. Here we can see that we just did it right now. So Bamboo is going to be called and is going to create a new build that is going to create then a new GitLab instance that is going to actually do the build for us. And here we have our notification that it's starting a new build, and we can see in the message that it's now a master build. So again, this has triggered a new pipeline. Here we can see that it just started running right now for a master branch. And this will actually create our master release. So we can take this time while the master package is being built and actually do an npm view of our package to see what version we have currently in our Nexus repository. Here we can see that we have still our snapshot version that was released 21 minutes ago, and we will run this command after we do a master release so that we can see that the dependency has changed. And we are now able to use this sample package in all our examples. And we have our notifications in Slack that we have a new package. So we have the ZZ package. We can see here now that it's an actual release, and we can verify this by going into our npm view and do running again to see that it has updated. So now we can see here that we have the latest version 1021 just now being published. And we have done a master release and completed our workflow. We are still getting notifications because of the build job that is being done asynchronously, and we will get also the full time that it took to build this master package. Because we are probably now using a cached version, it will take a lot less time. So you can see here how cache enables us to reduce the build time from 6 minutes to 3 minutes, and sometimes even less than 3 minutes to build a new package. And this is the speed and the automation that we have in place. And as you can see, we never touch a version file. We never think about versions because what we do is we use, as you can see here, our conventional commit messages. Our conventional commit messages are a very powerful tool that enables us to also generate metadata. You can see that we always generate metadata based on these packages. So for all the packages that we are building, we have a metadata stored again in a Git repository. As you can see, we use this metadata to generate multiple things. For example, we have this latest package that always has the latest build. And we can see here the same version that we just saw in our published package being committed here. So this is done in real time when one is done after the other. And this is a place where teams can come and see the changes happening also in real time if they don't want to follow Slack or if they want a more organized way of actually seeing the packages that have been built. We can also create more complex release notes like what can be seen here for my workplace, where we can see the packages, the version of my workplace, and also all of the packages that are contained in my workplace. Each of them, you can see the package going from one release to the other release, what issues have been done and fixed, and all of the release notes. And this provides a lot of context for release managers to put into production the version that they consider stable or that fixes a specific bug. This is the power of using the semantic release and creating all of this metadata. So our pipeline has run, our release has been done, we have verified both through npm view and through our release notes that we have a new release ready to be used. So let's go back and complete our flow. So let's jump again into our Git repository and check out the latest release chore. So as you can see, build.ui is what allows us to have all the advanced features in place. It does the tagging of this release. It then pulls back the tagging of this release into develop branch so that we are always able to move forward in an incremental way. We can see the status of the build that was done, and we can see that how the issue has been linked. So let's take a look again of the linking of the issue. Let's jump into Jira, and here we can request a review. In our case, we are just going to approve the review, and we are going to close this issue and consider it as accepted. And here we are done with our package, we can see here all of the commits that have been done, all of the pull requests that have been done, and the builds that have been done as well. So we have all the statistics that enable us to have traceability of this issue from the time that we got this request to the time that we coded the bug fix and the time that we did the build. And this is the power of the semantic release and of the fully automated pipeline. We never think about versioning. We never think about incompatibilities in the pipeline. We just let the pipeline run. And this is why we consider CSDR as a mature pipeline. And this has completed our example for releasing a package. This is a very simple workflow for just one package. We have hundreds of packages being built every day. We also have more advanced workflows. For example, for my workplace, we are doing deployments directly in the cloud. So let's jump just quickly for an overview of the pipeline for my workplace, where we can see a bit more advanced pipeline in this case. Let's go into our build. And you can see here that we have a build stage, a callback, and a notify like before, but we are doing also deployments directly in AWS, both for development and for test. The development is done every time there is a successful build, it's replaced this version. The test is owned by the test team so that they don't need a specific environment. They can always have the environment updated when they need it so that they have no breaking changes, no changes in their tests, and so that they can run their actual tests on a stable version. We can see here the environments that we have available on AWS and the versions that are currently there, the deployments that have been done. In dev, it was 15 hours ago, and in test 1 month ago. And we don't do only deployments to the cloud, of course. We also are using our own housed and hosted VMs. So in this example, we have currently these environments for our housed VMs, and for hosted VMs, we are currently still doing deployments of WAR files into WebLogic. So still using Jasper and still doing deployments into WebLogic. Here you can see the different types of artifacts that are being created. So we have WAR files and zip files. We never touch the artifact once it passes the test stage. The only thing that changes is configuration files. We always guarantee that the binary code is always the same, that the version is an actual version. It does not get rebuilt again and again when there is promotion of environment. The only thing that changes from one environment to the other is the actual configuration file. This guarantees us consistency and allows us to deliver the results that we expect in each environment. What this means is that we are not coupled into any deployment environment. We are decoupled and we can deploy to any environment using this pipeline. We deliver our artifacts into Nexus, and then from Nexus they can be taken anywhere. And this completes our demo. I hope you have enjoyed and understood the power of just following some simple rules in the workflow, and the conventional commit messages are all it takes to actually have all of this automation working for you. In case you have any more questions, we are available always on Slack and through our functional mailbox. Thank you. Hope to see you next time.